Yeah, my talk will be on the production, essentially the production and ordering and handling of our product, welded wire, and possible the delivery of it. Is this? Introduction. My name is David DeValm. I'm a professional engineer. I've worked essentially half my career in the wire industry. The other half has been in the consultant world, mainly doing transportation. So I'm well versed on a lot of where the product goes in our industry. A lot of the products that the precast industry will use our product for. My outline here and objectives are essentially to give my introduction, guidelines for specifications for the product, how do we get the material that we use, the production order, how we go through the production orders, and then some limitations on our maybe handling and delivering to a specific site based on our product, and then some conclusions I'll have for that. Does this? There. The guidelines we have, and we've gone over this, I'm just going to highlight them. Again, a primary is a 1064 specification. The next, we can make galvanized wire. We can do stainless steel, and we can do epoxy coated. Again, Chris went over those and how those are produced and sent out if need be. Some manufacturers can galvanize wire, but then you'll have an issue with the weld and the galvanizing there. You need to make sure that the galvanizing is not a compromise as well in that welding process. So how do we get, we have to get our material. We get all the raw material. Essentially, we have to recycle a lot of the steel, so we get scrap. We go through a melting process. We go through a melting process to get the chemistry we want for a particular order. And that's usually done through an electric arc furnace. And I'll have pictures of those as well. And then we melt those in a melting pot. And we'll cast billets, which are square ingots. I'll show that as well in the next picture. And we'll roll those to a specific size that we need for the order. Now, typically we can do 1/16 interval diameters, but we usually start with a 7/32 or go up to 11/16 inch diameter wire. And if you need metric, that's a 1 millimeter increment between 5 and 18. So for those that deal with the metric, I wanted to make sure we included you as well. And this is essentially the melting pot. Can make up about 65. It can melt about 65,000 pounds of steel, and then it pours into essentially a casting. So it casts up to 4 lines of billets, and then what we normally do is we take those billets once they've cooled, we'll put them into a reheat oven. And we'll reheat it, and then we'll draw it out to a particular diameter coil that we need. And this is in a coil bed as it's cooling coming off the thing. And then that cools, and then we'll take that to the manufacturing point. So, product orders. I need to draw my wire to a particular size for welded wire order. Now that rod that I take in a certain size I've made in an order, I may draw it down 20%. So I'm drawing that out. That's what the cold working is all about. I may draw it down up to about 20% reduction of that diameter. I'm also trying to look for what my strength parameters are going to be when I do that. So as Chris said, I'm just giving you a couple of different ballparks that are normally in the industry, but Chris gave you a lot more there can be of your steel strength that you can go up to. And then we need to choose our machine, so what we can do with that product and where it needs to be. One, in your order, we have different types of machines to do with different products, different welds, different size requirements, and different widths and lengths. And so we need to be able to put that in production for those different machines that we have throughout our manufacturing facilities, based on the specification of what is needed for the order for the client. And so we need to be able to put that in a production schedule for that machine or a couple of machines that may be able to do it throughout our plants and industry. And these are some of the ideas of rolling vertical or horizontal rollers. So they can come off in different ways, but they'll essentially be used in the production line, in the welding line. This is just a drawing equipment that's typically used. So you can see the size that we need in our manufacturing facility to actually make all these things work in the production order. And again, these are the typical types of welders and the different sizes you can see here. I wanted to show there's differences to the patterns that can be welded here, and there's different specifications, even limitations per machine. So we'll have to get a machine that can do the product and the size, depending on what your sizes are, what your diameter of wire size and your spacing size requirements are. So we'll have to line that out in a machine, put it in production order, and then get it in order with all the other products that we might want to have put out on this machine or on any of the machines that we have. So that's why it takes a while, specific orders, to get the order out, because we've got to go through the melting process, we've got to go through the rolling process, then we've got to lay out all the equipment to draw it, and then to put it in front of a welder. Some limitations in our manufacturing is essentially just the size of the machines, the size that the machines can handle in terms of diameter, the size the machines can handle in terms of width and length, the size that they can handle in terms of weight. The other things that we have are job specific. When we're delivering it to a site, how much can you handle? What's the weight that you can handle on site? What's the weight you can offload? So there's offloading and site requirement handling things. Also, if it's bent, if you have a product that's bent, are we going to bend it on site and send the bender with the product, or are we going to pre-ship it bent? And that adds to a volume that might actually reduce the weight. And so you have issues with bending and pre-shipping or pre-ordering it bent or bending it on site. And there may be some other constraints too throughout the specifications per job. So we have to order it and figure it out per job, how we're going to get it there, what we're going to do with it on the job. These are some of the pictures of the trucks that you can see here too in terms of this is an overwide. This is probably not fully weighted. And then again, we can fit combination of rolls or sheets on any one truck, depending on the needs of that client, or maybe this is two different areas of a project that they need different products. I want to go over this slide too, because in North America, essentially, it's a little different sometimes than the rest of the world. Some of the other speakers may not fully agree with this slide, but I wanted to throw it in here just because in North America, we often make orders to specific requirements, and so a lot of times what you have individual federal, state requirements, county guidelines, and I think sometimes it's a little different than the rest of the world in terms of a government, or the whole nation specifying. It's easier to specify a certain product for a specific area. The other thing that's different about North America is we use imperial, and then there's metric, and so I don't think I need to speak anymore on that topic. And then there's measuring methods and differences. In North America, oftentimes you design to a particular bar size, to a particular space, and then oftentimes we in our manufacturing convert that wire to an area and then produce that in terms of what we can make, like I said, with size, diameter, and spacing on our patterns for our machines. That'll work the best. It's made essentially to an area of steel. It's designed to an area of steel where I think a lot of times the world over, the design is also coordinated with the area of the steel that's input into it, so it's easier to supply the steel to that particular project. I know in the European and some of the other English-speaking countries that we are coordinating with or trying to collaborate with, I think the design is pretty much set in concrete to a particular area. And so that we have guidelines in the U.S. that tolerance, safety, environmental controls, and all those things we have to also look at when we're going through the specification and figuring out what the client would need with their particular product. I think sometimes, a lot of times in our industry, tolerances are a big thing, especially in precasting, and so those need to be looked at in a welded wire reinforcement application. Also, sometimes you have different inspectors on site or different requirements for DOTs that have a confusion on how to read or a different interpretation of how to read the code and the specifications involved. So you might have to educate somebody on our product and a wire product, what that is in terms of a contractor looking at it or in terms of an inspector looking at it in the field. In conclusion, our wire, I believe welded wire product is made like no other because we have a welded product that no other manufacturers worldwide make, and that wire, that weld is stronger than the actual individual wires. And so it gives what I consider, especially for finite element analysis, an alternate load path. But the issue is with our industry is we don't get credit for that weld having an impact, so we can't really calculate that weld as an advantage that we have for our product, yet it's not allowed because of what we've done with the wire in the manufacturing process. Is we've taken out a lot of that elongation with the 20% with stretching it before we put it in production, and so we get a little bit reduction in that elongation of our wire in the production process, and so I think that's part of the reason why the industry is still not giving us credit for that weld intersection. Again, our sheets are made to order. It's a specific size, specific area, specifics. And so all those specifics are changed from state to state, often region to region, depending on who's overseeing the project and the jurisdiction involved. And so we need to be looking at all those specifications and extra requirements beyond the specifications that that industry or that region and jurisdiction might put on our product for a particular application. But again, the thing I always like to note is it's a product that's standardized worldwide, and it's used worldwide, and it's been used throughout history to effectively speed up continue to speed up the means of construction and quicken the use of the end product and get it into market a lot faster, whether it's a precast, whether it's a slab on grade, or whether it's a full building mock-up. And that's my talk in its nutshell. These are some references. The top reference essentially is the Wire Institute. The next is our guide, comprehensive guide that we've been trying to get a session for, and this is what's the result of it. And the bottom is just my information, contact information if you have any further questions.